Next, we'll talk about section 3.3, which is called measures of positions. In addition to measures of central tendency and variation, there are measures of position or location. These include, number one, standard scores. They compare the mean and standard deviation. They're also called z-scores. The formula is z equals x, which is the data value, minus the mean divided by the standard deviation. When all data for a variable are transformed into z-scores, the resulting distribution will have a mean of 0, standard deviation of 1. A z-score is the number of standard deviations each value is from the mean. Okay, percentiles is number 2. Percentiles divide data into 100 equal groups. If a student has a score at the 70th percentile in the SAT, this means that the student scored higher than 70% of the students that took it. The formula for percentile is the number of data values below x plus 0.5 divided by the total number times 100. Okay, if I want to find the data value corresponding to a given percentile, I'll use C equals N, which is the number of data values, times the percent over 100. Quartile 1 is the 25th percentile. Quartile 2 is the 50th percentile, also the median. Quartile 3 is the 75th percentile. You can divide data into quartiles called the interquartile range, which is found by subtracting q sub 3 minus q sub 1. Deciles divide the distribution into 10 groups, denoted as d sub 1, d sub 2, etc. D sub 1 represents the 10th percentile, D sub 2 represents the 20th, etc. Outliers are extremely high or low values. The mean and standard deviation are strongly affected by outliers. To identify outliers, we're going to find the IQR. I know this PowerPoint is a little off. We're going to find the IQR, multiply by 1.5. Okay, hold on just a second. We're going to add this value to q sub 3 and subtract from q sub 1. Any data value outside this interval are called outliers. Okay, let's do a few problems. Okay, if you would turn in your book to page 159. And we're going to do problem 9. Alright, problem 9 says the average age of senators in the 108th Congress was 59.5 years. So that's my mean. If the standard deviation was 11.5, that means they vary by 11.5. Find the z-score corresponding to the oldest and the youngest senator. Okay, so erase what I just said. Let's change this to number 9. I was doing number 10. 9 says, if the average number of vacation days for a selection of various countries has a mean of 29.4 and a standard deviation of 8.6, scores for the average number of vacation days in each of these countries. Okay. The formula for z-score is the data value minus the mean over the standard deviation. So if I fill in for Canada, alright, Canada, it says, has 26 days, so that's 26 minus the mean divided by the standard deviation. Okay, you will punch that in. We're gonna round to the hundredths place, and I believe that's negative 0.40, which means Canada, since this is a position, is negative 0.4 below the mean. All right, next if I do Italy, okay, Italy says they have 42 days. So the mean is still 29.4. Standard deviation is still 8.6. Round to the hundredths. So they're 1.47 above the mean. And US, their number of vacation days is 13. That gives me negative 1.91. So US is negative 1.91, which means 1.91 below the mean. The question says, so if we kind of think about it then, the US has the least favorable number of vacation days compared to Canada and Italy. All right. Let's see about number 21. Okay, number 21. All right, 21 says the average weekly earnings in dollars for various industries are listed below. Find the percentile rank of the data. All right, what we need to do first is we need to put that data in order from least to greatest. So that's 228, 489, 524, 597, 623, 659, 736, 777, and 804. Okay? The formula for percentile rank is the number of data below plus 0.5 divided by the number of data values, and then we're going to multiply it times 100. Okay? So if I take 228 and I want to find the percentile rank for 228, there is nothing, no number below it. So that's 0 plus 0.5 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. That gives me approximately the 6th percentile. So 228 is at the 6th percentile. If I do 489, there's one number below it. That gives me the 17th percentile. 524, there's two numbers below it. That gives me the 28th percentile. Okay, etc. 21 also asks us one more question. It says for the same data, what value corresponds to the 40th percentile? Okay, there's a formula for that. It's C equals the number of data values times the percentage divided by 100. So the number of data values was 9. It wants the 40th 40th percentile number. Okay, we'll punch that in the calculator. That's 3.6. But we want to round to the nearest whole number, which is 4. Then I go back to my data and I count to the 4th number, 1, 2, 3, 4, which would be 597. So 597 represents the 40th percentile. Okay. All right, let's see. $25 says a random selection of state gasoline taxes per gallon is given below. Find the first and third quartile. Go back to your calculator, punch it in L1. You can go and see what quartile 1 and quartile 3 are. Quartile 1 is going to be 16. And 3 should be 27.1. Okay, last problem we'll do is 29. 29 says check each data set for outliers. We're just going to do A. Remember, an outlier is something that's like way above or way below. So if I look at letter A, I'm not sure if any of those numbers are extreme. There's a process, it's in your PowerPoint to find it. It says, first of all, to find Q sub 1 and Q sub 3. So punch the data in. Q sub 1 is 16.5. Q sub 3 is 20.5. Next, I gotta find the inner quartile range. So I subtract those, which is going to be 4. Okay, I take that number, I multiply by 1.5. Okay, then I take that number and add it to Q sub 3. Subtract that number from Q sub 1. So I'm looking to see if anything falls between 10.5 to 26.5. If something falls with not in that range, it is considered an outlier. So I see a number that's less than this, and it is 3. Okay, but there's nothing greater than that, so the only outlier would be 3. All right, and that should do section 330.